we are going to look at alternating series test. And it's section 11.5. Well, let's show you what an alternating series looks like. Any series in which the terms go plus takeaway, plus takeaway, plus takeaway, plus takeaway, like this. They alternate between positive and negative terms, as they do in this case here. It's called an alternating series. This is one written down the good old-fashioned way. You're more likely to see an alternating series test. What letter of the alphabet? Yeah, let's use K, just so I don't get used to doing N all the time. Oops. Right. That's the usual structure for an alternating series test. I'm going to mute it all. I'm getting some feedback here. Right, here we go. If you see a -1 to the k, a -1 to the k plus 1, or a -1 to the k, followed by pretty much anything, it doesn't really matter what it's followed by, you are looking at an alternating series. Okay, right. So in this case here, if I did it, you plug in k equals 1, you get -1 over 1 squared. When you plug in 2, that becomes positive. When you plug in 3, it becomes negative. And when you plug in 4, it becomes positive. You see that this -1 to the k is what generates the alternating plus minus thing. So they're pretty easy to recognize. Since the entire 11.5 has got nothing but alternating series in them, I guess it's not difficult to know that it is one. But can you try and imagine there might be a situation in the future where you just see the sequence and you're not told it's an alternating series test or a p-series test or anything. Oh, by the way, do you recognize that series here if I made everybody positive?
Harmonic.
Maybe the harmonic. Now, if everybody was positive, it wouldn't be an alternating series, right? It would be a harmonic. And it diverges, right? Right, p-series test, if you want to prove it. Really a guess, but maybe your gut feeling will tell you. Because every second term is being subtracted here, do you think that this alternating series, that's all we call it, no special name, this alternating series, do you think it might converge? What's your gut feeling?
Yes.
Yeah, it does, converges. Can you see that if you add them all up, it just gets bigger and bigger? But if every second one you take something away, won't it kind of dampen that increase? And it might, in this case it does, it dampens it enough that the thing converges. Are we good? So let me show you now the alternating series test. And this is a test to tell whether an alternating series converges or not. And typically I'm going to call it AST from now on, so I don't have to write that every time. This is, I'll go back to my ends now. Can you imagine that's just a general alternating series, right? Any alternating series in the world could be made to look like that guy. Right? Now, the alternating series test says if AN is decreasing and the limit as n tends to infinity of AN is 0, the series converges. And if the limit as n tends to 0 of AN is not 0, so it's just a number, and that number could be 4, that number could be infinity, right? Just not 0. Then the series diverges. So there are two pieces to the alternating series test. There's the first one, it needs to be decreasing. And then the second, the limit of the guy needs to be 0. Okay. Any questions about that, or does that, it's a test, that's what you do? Very cool. Let's show you an alternating series that diverges. Let's show you one of them. Okay, whoops. There's your guy. Now, this piece here is not mentioned. So we essentially, for the test, you ignore its existence. It doesn't really matter what it is. So the guy that we call AN is always this piece. Not the whole thing, but just this piece. Right. Now, I could do step 1 and then do step 2, but actually you tend to do step 2 first, and I'll show you why.
Is it plus n or is it plus 1?
Is what plus 1?
Because at the top it says plus n squared plus 1, and then the rest of it just says.
Oh, okay. Let's just change it so I don't need to fix it. It should have been 1 all the way through. So we got this guy. Now, couldn't I find the limit using L'Hopital? Maybe do it a couple of times. Couldn't I find the limit by another means? What would be the other technique? In fact, it's going to be the one I'm going to use for finding this limit.
Divide top and bottom by n squared.
Have you noticed that there's a skill that we're using that keeps popping up all over the place? Finding limits of things seems to be a skill, right, that we're using a lot. Now, this fella becomes 1 plus 1 over n, 2 take away 1 over n. Would it be fine for me to go straight into a half? You're comfortable, but the limit of that would be a half. Now, if the limit is not 0.
Sorry, the denominator
Again?
is 1 over n squared, isn't it? Instead of 1 over n.
I think what your question is. Is the denominator?
Oh, okay. So yeah, the denominator, isn't it supposed to be 2 minus 1 over n squared?
Oh, yes. Yes. We're good now? It's still a half, but you're right. I was wrong. Now, if the limit is not 0, which is in this case here, I can go up here and I can say it diverges. And haven't I saved myself a bit of work? because I haven't bothered to prove that it's decreasing. And I don't need to. If one piece is broke, it's a diverger, right? The whole thing diverges. It's only going to converge if both pieces are correct, right? So let's try one that converges then. Try that one. Which, by the way, happens to be the one that I started today with. That's what it looks like if you wrote it out. And I said that one's converging. So we are going to prove that this one converges. Now, for convergence, both these things need to be true. For divergence, doesn't just one of these things need to fail? Typically, the second one's the one that doesn't. So let's see what we get here. AN, in this case, is just going to be that guy. You notice that you forget about the -1 n plus 1. It doesn't take part in the test. Now, for that guy, I don't think I'm going to have much of a problem proving that this is going to be 0. Would you agree? Just brute force. Agreed? Now, I'm now going to take this guy and turn him into a similar looking real valued function. And the reason I'm going to call it this guy rather than that is that, technically speaking, and I know it's kind of being lawyer-esque, but isn't 1 over n only when n is 1, when it's 2, when it's 3? It's not a real curve. It's dots in space. So if I call it this function, would you agree that this behaves just like that? It's just this is the real value function. And why do I need that? Because I want to prove decreasing. And to prove decreasing, you find derivatives. What will be true about the derivative of a decreasing function?
It'll be negative.
It will be negative. At least it will be negative for values of x greater than or equal to 1, right? Because 1, 2, 3 are the n's that get used. In this case here, to be able to differentiate it, don't I need to call it x to -1 so I can use the power rule? And that ends up being -1, right? Multiply by the power, reduce it by 1, make it look pretty. And now I'm going to try and prove to you why that is negative, at least for values of x greater than or equal to 1. We are allowed a little wiggle room here. Do you know sometimes it has to be greater than or equal to 10? You know, the first few numbers might jump up and down a little bit before it settles. But we'll start with 1. Would you agree -1 is always negative? Would you agree that x squared, as long as x is greater than or equal to 1, is definitely positive? Isn't a negative over a positive negative? Haven't I shown that the derivative is negative? I mean, that's the way I'm proving it. And since it's negative, AN is decreasing. So its limit is 0 and it's decreasing. That means this alternating series is a converging alternating series. Are we beginning to get a feel for how this test works? Find the limit as n tends to infinity of the AN bit. If it's a number, end of story, it diverges. If it's 0, then you go and you prove that it's decreasing by finding its derivative and showing that it's negative for values of x greater than or equal to, 10 or whatever. Okay, let me try one. Here's one. This one is similar to question 5 in the homework. And I don't know why my sigma looks like a C. I'll try and make it more like a sigma for the next question. In this question then, AN is that guy. The only guy that you ignore is the -1 to the n. And I am going to find the limit as n tends to infinity of this guy. But I am going to change just a little bit how it's written. Why do you think I'm taking this guy and writing him as that guy? What do you think the advantage of doing that would be?
It looks nicer.
Yeah, isn't it easier to plug in infinity and do brute force? I know what e to the infinity is. Isn't e to the power of infinity infinite? But isn't e to the power of negative infinity just a little bit harder to get your head around sometimes? You know, is e to the negative infinity? Is it 0? Is it what? You know, I'm not sure what it is. So if you do the brute force, we get 0, which means it's cleared hurdle 1, hasn't it? Agreed? Now, I'm going to look at this function, and if it is decreasing, then we are good to go. That series converges and you move on. So I'm going to look at that guy, right? Same function, but with x's. And now I should be able to do its derivative. It's not the hardest derivative in the world. Don't you get 3e to the negative x times that guy? And again, I'm going to write them like that. Here goes. Would you agree that -3 is always negative no matter what x is equal to? Hopefully it's obvious. Isn't e to the power of x a positive number, right? E to the power of 1 is positive, e to the power of 10 is positive. And if you have a combination of these two, won't the answer be negative? So since this is negative, this guy is decreasing.
Where did the -3 come from?
When you differentiate e to the negative x, you get e to the negative x times -1.
Oh, yeah, sorry. Thank you.
And in this case then, can't we pick converges? So for an alternating series test, this is the process, right? Okay. Trying to see, okay. This isn't that big a change, but I'm picking it because I think it's going to be messy. In this question then, oh, darn it in space. I need to find out what's happening as n goes to infinity. What's your gut feeling? Do you think it's going to be a number? Do you think it's going to be 0?
I think it's going to be a number.
Okay. Maybe. I need to find out what it is going to be, right? And that's why I said, oh, darn it, because when I picked this question, I thought it was going to be awkward. Now that I've written that down, I am certain it's going to be awkward, right? How do I find out what this guy is equal to? I could do it 2 different ways. First thing I'm going to do is just rewrite it. Like that. And we've used this trick before, but we've used it with nicer situations. You know the one where you divide top and bottom by n squared, or divide top and bottom by n, that kind of technique? We've used that before. I'm going to use that technique, but I'm going to divide top and bottom by n to the power of half, which is not your typical divide thing, but it works. If you divide this by itself, you get 1. If you divide this by n to the half, can you trust me that you get n to the 1/2? And if you divide this by n to the half, you get an even uglier guy that looks like that. If it helps you, you might want to turn things back into square root of n's. Okay, now I can do brute force. 4 times square root of infinity, isn't it infinity? Plus 7 over the square root of infinity is that. 4 lots of infinity are infinity. What will 7 over infinity get me?
0.
Agreed, 0. And isn't 1 over infinity 0? Hey, it's past the first hurdle. It was 0. Now, I said there's 2 ways to do that. Anybody got a guess at what the second method would have been?
L'Hopital?
It would be. It's ugly, but it would eventually work, right? I think if you finish doing L'Hopital, it ends up being something weird like 1 over 14n, which gives you 0. So it would have worked, right? I'm just not going to do it because it's extra time, but you can try it out if you want. I'm not saying that's particularly pretty because that was pretty ugly as well. So it's not like either method was brilliant, you know, clean. Both are ugly, so it really doesn't matter what you got. Now,
Could you have divided top and bottom by n?
yes, that would have worked too. Actually, I think that would have worked and been slightly nicer as well. I think that it would have looked prettier. Yeah, you've got a bit of flexibility on that process about which one you decide. The reason I chose that one is make that one. I'm assuming that you said n because it makes this a 4. So you don't just randomly pick an n. You don't say, oh, I'm just going to divide the top and bottom by n cubed just to see what happens. Doesn't the candidate have to be the square root of n or n in this question at least? That's the only 2 you could do it with. Now, the real valued function is going to be x to the half over 4x plus 7. Because we're not finished unless we prove that this guy, written in this format, is decreasing. Calc 1, differentiating a fraction. What rule does come to mind? I didn't quite catch that, it was a bit quiet.
Quotient rule?
Correct, quotient rule. So I'm going to pick this as f, I'm going to pick this as g, and our derivative, according to the quotient rule, is f dashed g take away f of g dashed all over g squared. And if you differentiate this, you get 1/2 x to the negative 1/2 times, leave this guy alone, take away this guy times the derivative of him, which is 4, and the whole thing is over that guy. Oh God, this is ugly, but keep going. 1/2 times this guy gets you 2x to the half. See why that happens. A negative a half times a full x. Put them together, you get a half. The second guy gets you 7 halves x to the negative 1/2. And the last guy gets you that fella. And it's all over 4x plus 7 squared. These combine, and now I've got 7 halves of this guy, take away 2 of this guy, all over 4x plus 7 squared. And now I'm going to take this guy and call him that. And why have I got an extra x? Take away 2 of these, all over 4x plus 7 squared. And I'm deliberately choosing a bigger value of x. Maybe I should make it 9. There, that's it. This top expression is not easy to look at, but it is possible to do it. Would you agree that once x gets reasonably big, won't 2 root of x be more than this fraction? You know, can you imagine by the time x gets to 100 or something, won't this be bigger than that? Which means, won't you get a negative answer on the top? Would you agree that something squared is always positive? There's the decreasing that we need. And that makes this converge. So my argument is that as long as x is bigger than, say, a number like 9 or 900, as long as it's a number you can find, this take away this will be negative. And the reason for it is that 7 over 2 root x gets quite small, doesn't it? Can you imagine with big x's, that's quite a small number. But won't 2 root x be much bigger than that? And a small number take away a big number is going to be negative. So just thinking it through in my brain, that's what we got. Are we cool with that guy? Any questions before I move on then? I guess one of the saving graces is that, at least for the ones we've done so far, isn't it a process? Find the limit as it goes to 0. If that's a number, it diverges. If it's 0, differentiate the function and prove to me it's negative. If that works, you converge. Oh, sorry. Square root of n cubed. Square root of n cubed plus 2. Before I tackle that question, something I think I should have mentioned, I'm going to mention it now. Do you know this guy we just did a few minutes ago converges? Do you know if that says n plus 1, it still converges? Suppose that said n take away 1, it still converges. So do you see this alternating? The only thing that does is it makes you start with a positive, then go negative, or it makes you start with a negative, go positive. If the thing converges, that has no effect on the answer. So if I was doing, hopefully the next one is up. Do you know how this one converges? Wouldn't that one also converge? So that's that one. Do you see how this one here diverges? Making this n plus 1 doesn't help it. It still diverges. Okay, so the negative 1 to the n, or n plus 1, or n minus 1, whatever they decide to use, those guys have no real effect on convergence or divergence. It's what this does that matters. Right, let's look at this guy. Do you think it's going to converge or diverge? What's your gut feeling?
converge.
Any particular reason, or it just looks like it would?
The bottom looks like it's gonna get bigger than the top.
That's pretty much all you need. If the bottom gets bigger than the top, you'll find that most alternating series converge. Most, there's got to not make that a blanket answer, but most of the time. So in this case here, we're going to do the limit as n tends to infinity. What technique could I use on this one? Because we only have two, L'Hopital or divide top and bottom.
L'Hopital.
Oh, God in Himmel. No, Sam, please. I'm not going to do it to prove to you it's wrong. I can understand why you might think that. Is it just because it looks weird and L'Hopital might be how to get out of a horrible place? Yeah. In general, if you ever see a square root or a cube root, keep away from L'Hopital. And the reason for that is, what happens when you differentiate square roots in L'Hopital? Don't they get really ugly really quickly? Right. So in general, if you ever see a square root or a cube root, don't do L'Hopital. That would be my advice. Which means I've now stranded you with the other choice then. And don't worry about getting it wrong. It's the first time you've seen a darn thing. How do you know what it's going to be until you've seen two or three? Right. I'm going to divide. Any suggestions for who I could divide top and bottom by? Because we have a bit of flexibility.
You can do divide both sides by n to 3/2. It's the power of 3/2.
Oh, okay. So divide top and bottom by the square of n cubed, which is what 3/2 is.
Yeah.
Right. Yeah, okay. So let's see what that gives us. Works really well with the bottom. You get a 1 plus 2 over n cubed. A bit messier on the top, but I'll do it to the side. If you take an n and you divide it by that fella, maybe call it 3/2. Don't you basically subtract one from the other, you get that, which eventually gets that, which gets you that. It's messy, but it is what it is. Are you happy about that being 1 over n? 1 over the square of n. 1 take away 3/2, -1/2, which is that. Right, do brute force. 1 over infinity gets you 0. Square root of 1 plus 0 gets you 1. Exactly what we're looking for. You agreed? Now, this is the second part where things get crazy. This is, by all intents and purposes, the ugliest looking function that we've seen that we need to differentiate. Isn't it going to be a quotient rule? So it's going to be f dash g take away f of g dashed over g squared. The g squared is the only decent thing about it. That's easy. Aren't we going to have problems on this piece here? So let's see what this is. Differentiate this as 1. Leave this guy alone. No biggie. Leave this guy alone. And oh dear. How do you differentiate that guy? How do you differentiate that guy? What method?
Power rule, right?
Yeah. right? And isn't it going to be a chain rule as well? And so when you differentiate it, you're going to get 1/2 x cubed plus 2 to the negative 1/2 times 3x squared, and that becomes 3x squared over 2 lots of this guy. And we get 3x squared over 2 lots of that guy. Right. And now I'm going to cheat. This is not so much a proof as a intuitively correct. Would you agree that when x gets really, really big, that this piece here is going to be much bigger than that piece there? Can you imagine 3x cubed over this square root is going to still be bigger than this square root? So does it not make the top negative? And isn't x cubed plus 2 going to be positive as long as x is reasonably big? And so you've got the classic negative on the top, positive on the bottom. So it decreases, and we have finished the job. It can and it does happen that sometimes the derivative is just so ugly that the only way you can prove it decreases is just by saying, it seems obvious to me that the top is going to be negative because this guy is always going to be eventually bigger than that guy. It's not a real formal proof, but it's enough to get us by. Okay, let's show you another diverger. Well, and for some reason that turned into an n. There we go. Let's find the limit of the inverse tan of n. Now this is a brute force question. And I've done this at least twice before, so it must be getting a little bit clearer each time this happens. What does that guy look like? Because he is a number, isn't he?
Is it pi over 2?
It is. And what does that tell me about this series?
It
If the
diverges.
limit's not 0, it diverges. Can you see why you probably want lots of diverges on your homework? Because aren't they just a lot less work? Are we good
Is there
with
an
that?
example of like where one rule works but the other one doesn't when you're testing it?
Which means it's going to diverge, right?
Yeah.
Yeah, I should be able to figure one out. I'm trying to see if I can see one in the list here. And the short answer is I cannot find one. And if I just randomly picked one, it probably wouldn't work. But it is possible that you could have a series. Let's try and see what the combinations would be. Well, we have done one. They're just so obvious we didn't even bother about it. Suppose the limit is not 0. Couldn't you be decreasing and not have a limit of 0? I can do that one.
You cut off.
Am I,
No, I think that was
can you not
me.
hear me now?
Would there
Okay.
be a case where you're converging but increasing?
No. And the reason I could think that is that if you're converging, and you have to converge to 0, right? You can't converge to a number, because if you converge to a number, it's divergent, right? So see this guy here? Can you trust me he's decreasing? I mean, it's easy to prove. But isn't his limit 1? So there would be an example of one of them working and the other doesn't. And so Kathy was saying, is it possible that we could have a series that's increasing, right, with a limit of 0? And the reason you couldn't get that is the only way that could happen is that if all the ANs were negative. Agreed? But if all the ANs were negative, wouldn't this make half of them, wouldn't this here make, well, what's the word I'm trying to say? Yeah, the AN must be positive numbers. It's not allowed to be negative numbers. If the AN is a negative number, the alternating series stops working because half the numbers change, or at least the negative ones change into positive numbers, and you don't get that nice zigzag pattern. It's not very convincing, is it? I can't. No is the answer. I don't think I've gave a convincing evidence for no. So that's my gut feeling. Let's look at a different situation here. I saw a really interesting one when I was scanning through looking for things that didn't work. Now I can't find the darn thing. It had a factorial in it. So where are you hiding? Come on, factorial, come out of the woodwork. Oh, here we go. Right. The guy that we're going to deal with is this fella. And the limit as n tends to infinity is almost silly. Would you agree it's definitely going to be, 2 to infinity and infinity factorial, not, God, infinity factorial would be a scary number. I mean, it would be, not only is it infinitely big, isn't it infinitely big? Because it's got an infinite within itself. Second part is proving this is decreasing. I am not going to use calculus because you can't really differentiate x factorial. It has no real meaning. I'm just going to use logic. Would you agree that as n gets bigger, that this gets smaller? When you plug in 1, then you plug in 2, then you plug in 3. Would the argument be that this gets smaller and smaller? Why? Because don't these things get bigger and bigger? And so my proof of decreasing wasn't anything calculus. It was just, it's obvious to me that it is. In which case this guy converges. If I gave you this fella to do, and I asked you to find out if it converged or diverged, we would need to convert it into that. And although we know it doesn't matter as far as the test is concerned, don't we need to figure out, is this going to be that or that one, right? I guess you could do that one as well, right? One of these is going to make this happen, right? Which one of these three will make you start with a positive number? Would that make you start with a positive? Would this make you start with a positive? Or would this work? Which of the three is it?
N minus 1. N plus 1.
Actually, both. So you can use that one or the other one, it won't matter. They do exactly the same effect. Now, in this case then, would you agree it doesn't take too much except brute force to prove that 0? Would you agree? If I was going to do the f of x thing, although that's really ugly looking, if I call it that, can't I use a chain rule? And its derivative then is -1, the natural log of x to the power of -2. And since it is a chain rule, what do I finish with? What's the derivative of log x?
1 over x.
Okay. And if I make it look pretty, would you agree the top is -1 and the bottom is always positive? And there's the negative that you need to prove it's decreasing. So that guy there is a converging alternating series. Okay, we'll call it a day. So if you all want to say hi for attendance, if anybody has any questions, because I know at least one person does, but there might be others, just hang about and I'll see if I can help.
Have a good one.
You too, bye-bye. Okay, who's first, who's second, who's third? I guess that's the question. All right, you did ask first, so you can go first. What you got for us?
It was question 12, 11.3.
Okay, is that a short one, or shall I go looking? What is it?
I believe it's a short one. It's just,
Okay.
but if I'm not for sure, I can let other people go ahead if they have.
No, I just mean is it short in the sense I can write it down. I don't care how long it takes me. Something I can just write down.
yeah. Yeah, you can write it down. Yeah.
Okay, you got it handy then?
Let me. I can get it real fast. Because WebAssign likes to kick me out now every 10 minutes.
Who does?
WebAssign.
WebAssign. Yeah,
it
it has a time feature on it. Yeah.
Yeah, it didn't have it last quarter. I don't know why they implemented it now.
I don't know. I thought they did, but maybe I'm wrong. It's to stop people putting on WebAssign, going and watching the movie, and then coming back and telling me I spent 8 hours last night on WebAssign and couldn't do one question. You know, there are some people out there who just tell lies.
Yeah.
And so now WebAssign boots you out. So the best you can do is 12 minutes and then tell me that you spent 12 minutes last night not being able to do any questions.
All right, I have the question. So it says determine whether the series is convergent or divergent. It's infinity over sigma n equals 1. It's 2. It's e to the power of 1 over n to the 9th power. And then divided by n to the 10th power.
Okay. And this is an integral test question, right?
Yes, yes.
So I can focus on finding out what that does. If this converges to a number, then that converges. If this is infinite or diverges in some other way, then the series is divergent. Do you recognize the technique that I'm about to use to solve this integral?
I want to say U sub.
You are correct to say U sub. Have you Any idea what the u sub
I'm
should
I'm
be?
gonna say the u sub is going to be x to the power 10.
No, I know that's where it went wrong. And I know why you picked that. Because 9 times out of 10, if it's a fraction, isn't the guy in the bottom the u sub?
Mm-hmm.
Right, that's a very common u sub. But there are exceptions to every rule, and this is the 1 in 10 exception. So since I've said no to that one, who else could be your u sub then?
I'm gonna say then we go for the next ugliest thing. I'm gonna say 1 over x to the ninth.
Correct. That is, in fact, going to be the right one. I'm just going to call it x to the negative 9 to make it easier to differentiate. If you differentiate with respect to x, you multiply by the power and you reduce the power by 1, which is fine. If you do the crossover, you get that. And if you isolate it, let me bring this over, you get you get 1 over negative 9 x to negative 10 du.
Oh, and then okay.
Can you see where it's going to go to now?
Yep, because
So you just take it a little bit further. You're going to have e to the u over x to the 10. I'm going to rewrite this guy as x to the 10 over minus 9 du. And what that does then,
crosses out.
it crosses out. And I am basically looking at that guy. Would that be enough to figure out where to go from there?
Yes.
And I believe that this thing will eventually converge. It's my gut feeling as it will.
I would.
But remember to turn things back into x's at the end before you start plugging x equals 1 and x equals 10.
All right.
Okay. Have you got anything else? Any other questions?
I had a question about 7 on 11.3 as well, because it was kind of one of those weird
Okay,
ones.
What was that one called? Sigma.
It was sigma. It was 3 over n times ln n. Hopefully
that guy. Yeah.
Yep.
Okay, so the integral from 1 to infinity of this fella, which becomes, the limit is t tends to infinity.
Wait, is it 3
Oh,
over n?
Yeah, misroll. There we go. That should be an x, by the way. Finally got it. What's your gut feeling this time? What method do you think I'm going to use to integrate this really weird looking fraction? We don't have a lot of choices, do we? It's definitely not a power rule.
No.
So u sub. Not an obvious u sub, but it is a u sub. So who on earth is going to be the u sub?
Would it be ln of x?
It will. So we now get the limit as t tends to infinity of 3 over x. 3 over x u times x du. Now, that guy is 3 natural log of U's. Which you need to make sure that you convert it back to x's. And now you're going to see an even weirder looking guy. The natural log of a natural log. You don't see that every day. So what's going to happen here is it's going to be the limit as t tends to infinity of 3 natural logs. Does that question start at 1? I'm just curious because I don't think it
No,
does.
it's just at
Does
2.
it start at something like 2? Yeah. That's not going to make a big difference, but it is going to make a difference at the end here. So it's going to be the natural log of t. Take away 3 times the natural log of 2 there. That's much nicer. If t goes infinite, this is brute force. If t goes infinite, won't the log of t be infinity?
Mm-hmm.
And won't the log of that infinity also be infinity?
Mm-hmm.
And so the whole thing is infinite. And since the whole thing is infinite, it diverges. Okay, Sam or Douglas, have you got a question?
Nope.
Just sitting and
No.
watching.
Yeah.
No, that's
too.
totally fine. I like that. You too. If do we have any more questions from you then? If not, then
I think.
Oh, keep thinking.
I think I'm all good.
Are you good?
Those are the only ones I really had troubles on. So.
Okay, so bye-bye then. Unless I've
Bye-bye.
got another question.
Thank
I'll see you tomorrow.
See ya.
Have a good day.
You're welcome. You too.